How long do I have? Is it 50? God damn it. So the thing is that I submitted this, and I didn't realize that I got a 50-minute slot for it. It was a surprise, especially when I saw this before I finished the slides, or started the slides, actually. So if you're looking for Leo's talk, it's not here. If you're looking for the other talk that was here, it's also not here. Okay. So I'm going to talk about PSGI and Plack for fun and profit, but mostly profit. And this is a topic that I'm actually very, very excited about. I'm going to move this out of the way so those sitting in the front could see everything. And it's a topic that I really enjoy. I'm really excited about. And now I get to talk to you about this topic in kind of a way that I don't usually get to talk to, which is from the direction of a very large company that uses this technology. And I get to show a completely different direction of this that I find absolutely fascinating and kind of different than when I usually talk about this as like, this is cool. So what I'm going to start with is tell you what I'm going to talk about during the talk so you could frame it and know how it relates to what we're doing. First of all, I'm going to talk about PSGI as a protocol, try to explain how it works, how it looks, how it interacts with everything. Then I'm going to talk about Plack as the utilities that we have to implementing and using PSGI applications and servers. And then I'm going to talk about how large business considerations tie in with Plack and PSGI, or alternatively with PSGI and Plack. So PSGI and Plack, you should know that it was actually lifted from Ruby that has something called Rack, and Python that has something called WSGI, and they were both lifted. It was Miyagawa who actually did this, and he does wonderful things. He did this too. This is, by the way, something by Banksy that I absolutely adore, and I added my point. So the structure of a PSGI application, if you take a look at this wonderful drawing that he did, usually I have a balloon for the user. I couldn't get it in ASCII. Any ASCII experts see me after. Basically, when you have a server and it runs Apache, and you want to interact with a CGI application, you actually have the application on the outside, and you call that application. It will run an interpreter, call the CGI application, run it, and return a result. Now, if we have PSGI, what we will do is have our Perl web application written in the PSGI protocol instead of CGI protocol. And then we will have something called a handler that allows us to translate how the server sees a request into PSGI, which the application expects. And what the application returns will go through the handler to translate it back to the server. So the handlers actually do all the heavy lifting, so you don't have to do any of it. Now, this is a different structure. If you're using mod Perl, this is a bit more familiar. What happens is that the web server actually has an instance of Perl running within it, and it uses the handler. In this case, it would be, let's say, mod Perl, for example, or mod PSGI directly, which will, again, do the same thing. Now, I am noting here that the PSGI web application is actually implemented as a callback. It is basically a function. And that single function will receive, through the handler, the request that the server received from the user. So I'm going to go through it one more time because it is important for you to understand. The user sends a request. The server gets it. The server uses the handler to translate it to a protocol called PSGI. And then it calls a function, one single function, to run this. And the app, because it has the handler, can assume that it is in a very specific structure. The app will then return, using the callback, a specific response. The handler will understand this and translate it to the server. Then the server will return it to the user. Of course, nothing speaks like application examples. And we're going to use some examples for PSGI. I don't know where Sushi is, but I should get points for also using cat pictures. So when we talk about the stuff that is actually in this callback, this is an example of a PSGI callback. you have a sub here. It gets the information using env, which is a hash reference that contains everything in a request. It defines the entire request. The handler actually takes whatever the server has and translates it to an env, and then calls our function with that env. And we can use that env to probe into the request, understand what the method was, what the path was, decide how we want to handle this, and then we will return a response. Now, there are 3 responses. I'm going to go through all of them. The first one is a very simple array reference that contains 3 elements of a response. One is the exit code, in this case 200. The other one is any headers in pairs, so in this case content type. And we can continue to add more pairs of headers. And the third element is basically the content. The content can be either a string, a scalar, or a file handle. That will also work. Something a bit more advanced is if we want to be able to return later. If we want to be able to delay the response that we're giving, which is something that is way more advanced than what we're used to, but it is very effective and very useful for a lot of situations. So if we have some asynchronous request that we need to run, what we can do is get the env, and instead of just returning that array reference saying, I already know all of these details, we do something else. We say, we're going to return code that you will run, and then you'll get the response. So this is the code. Return a sub. The sub will receive another callback called responder. If we have an asynchronous request like fetch content from server, which will run in the background, and we give it a callback to run when it actually receives content from server, and we get that content in that callback, we can use the responder that we received and send it the details, 200 headers, content. Now, some of you might have a question on, wait, I actually know with asynchronous of another option, what if I want to return the content gradually with time? I want to have it chunked. CGI, for example, when it runs it, it actually takes it as soon as it gets it and sends it to the user. So if you're using CGI and you're printing to the screen, which is, of course, super intelligent and a very smart protocol, it will actually take it and send it off to the user as soon as it gets it. But here you don't have this. Here, you're just delaying it, but you're still saying, here's all of the content. What if I want to send some of the content now, some of the content later? PSGI, even though it's very simple, it actually contains that ability as well. What it does instead is say, OK, we're going to turn a sub again. This time, I'm going to call the responder with some of the information. I'm going to say, I know what the status is, I know what the headers are, but I'm not giving you any content. And if you don't give content, it says, OK, let's do something else. I'm going to give you an object, a writer. And when you have content, you send to the writer. When you're done, tell me you're done, and I'll close the socket and close the connection with the client. So if I have an asynchronous request, wait for events, it has a callback that receives an event every single time, I can check if I actually did receive one, and then call the writer with some data. It will send that data to the user right away. If it's called again, it will send that data, some more data. Once we realize we have no event, we can tell the writer, we're done. Close the socket with the user, end this entire request. The good thing about delayed response streaming is that the server is then able to run this in a loop without blocking the entire user request. And that is something that is very, very important. If you are making a synchronous server that has a single thread and it has sleep in it, that's it. There's nothing that you can do about this. So what you do is increase the children. But what if all of your requests are longer? So what we usually do is we throw it out somewhere else, Beanstalk D, Redis, whatever else we have, because we just can't handle this right now. So we're putting a note somewhere else saying, oh, we actually do need to handle this in the background, so let's put it somewhere else. In this case, you can actually handle it in the background, and it's fine. If it takes 5 more seconds, run it in the background. Allow the user to have a request that is completely handled without having to throw it out to an external service, and allow the server to run a loop that can actually delay some of these responses without needing more children. So now that we understand how a PSGI app looks like and where it actually sits, I want to talk about Plack a bit. Plack is the major piece that we have when we write PSGI applications. It is actually just a bunch of utilities that help us implement all of this instead of writing our own code just like we just did. There's in this toolkit, there are several elements that I would like to cover. There are a few more, but they're not very relevant for this. The first one is the handlers. I'm going to put this a bit closer because my eyes are not what they used to be. So handlers are the web server adapters. They basically help us translate everything between the server, what the server sees as a request or as a response, and what the PSGI protocol says. It stipulates you have to provide it as an env hash. I don't care if you don't have it as an env hash. You have to translate it to an env hash and then send it. And that's what the handler does. The runner, which is a command line to load all these PSGI applications and servers. Middlewares, which are fascinating. They're basically nice wrappers around the PSGI app. The builder, which is a nice DSL for enabling all these middlewares. Testing, there's a lot of testing in Plack, both for the application and both for the server. And this helps mock all of this environment. So if I want to run a request just to test and see that my application works, I will have to run a server. But with the abilities of Plack testing, I actually can say, well, I don't want to run a server. I just want to run this. No sockets are open. It fakes an entire server within it. It's pretty cool. So I'm going to go over one by one. First of all, handlers, the adapters. They connect all of these application servers together. For example, there is a handler for Apache 1, Apache 1, and Apache 2. And these handlers allow to use mod Perl 1 and 2 and have them connect to a PSGI app. And the PSGI app doesn't know that on top of it is mod Perl and Apache. It doesn't care. It just implements that sub, completely separate from the environment it is sitting on, which is absolutely crucial. And they allow you to handle those cleanly. There is a handler for Starman, which is a pure Perl server that does pre-forking, is high performant. There is Twiggy, which is a server written in any event, which is an event loop. So you can have handlers to these servers as well. You have a handler for CGI. So your Apache is configured to run a CGI script. That CGI script actually has a handler to translate your regular app to CGI, back and forth. So you're still running on CGI, but your app doesn't know and doesn't care. And when your setup changes to mod Perl, you just use this handler instead. And suddenly, it's running on mod Perl. And if you want to run in a fast CGI, you just use the fast CGI handler, which is Plack handler fast CGI. There we go. So you can actually move your application around between different setups, and your application doesn't change, and your application doesn't care. And this is amazing, because if you've done web programming at all, it is a nightmare because of the different environments that we have and different servers that we have. This is an example of how the Apache 2 handler looks like. You have in your config a location. You have to set the handler. This is all like disgusting mod Perl shit. But you can actually delegate and say, well, I have a variable PSGI app that goes to this place. And I have a startup. And this is how the startup is going to look like, which will load everything, use the handler, and call your app. This file will contain that sub. This file will contain another sub. So you can run applications. And your subs that are implemented in those files don't care about all of this thing. Once you move a server, maybe to Lighty or maybe to Nginx, or you move to Fast CGI, you can just remove this and use the Fast CGI handler. Your applications implemented in this nice PSGI sub in those files don't care at all. And not caring is very good sometimes. Runner. The runner is a CLI. It's a command line to just load and run all of these. There's a few stuff that you can do with it. It's really nice. It's called PlackUp. You can just call PlackUp. And then it looks for a file app.psgi. It runs do on it, or require, I think, do. And then it actually says, well, the last thing in this file will be the result that I get. So if the last thing is a sub, I now have a sub. And then the requests that are coming in, I'm going to call this sub. And you can ask it to load the sub from a specific file. You can ask it to load a specific server, maybe some parameters to that server. So this will load HTTP server simple. You can ask it to start a fast CGI server. It will load Plack handler fast CGI, and it will set up a socket file for you. And bam, that's it. You now have your app on fast CGI. Now use whatever web server you have and whatever mod fastCGI you have there and connect them. That's it. And now you can switch servers to a different server and use the same fastCGI socket. This is an example to make it listen important fastCGI, bunch of stuff. Middlewares. Middlewares are incredible. Middlewares are basically nice wrappers. So you have your app here in the middle, and then you wrap it with a middleware, and you wrap it with another middleware, and another one, and another one, and another one, and it kind of looks like those disgusting candies that you had to lick for like 70 days straight. So, right. So the nice thing about this is that each middleware only knows that there is the app. The app might actually be the middleware inside it, but it doesn't care. And the middleware, this one, can call the app as well. In this case, it is the app, but it doesn't care. It just says next. And middlewares can do 3 different things. It can do any of these or all of these. First of all, when a request comes in, it doesn't go into the app. It goes to the first layer, which will be the middleware. So the middleware gets an env. And the middleware can say, you know what? I can actually change this environment. I can add something to this environment. I can play with this environment. I can read from these things. I can do whatever I want with it. The second thing the middleware can do is forward it to the next path, which would be either the next middleware or the app itself. The middleware doesn't actually know. It just says next. So it can actually decide not to do this if it wants to, which is even stronger. So for example, your middleware can get a request and look in the env for the request method, which would be get, post, put, whatever you want. And then you could say, well, if it's not from a list of ones that I know, the hell with this. And it just returns the response back. It doesn't even continue to the next one. So your middleware just checked for you whether it's a method that you are willing to handle. And your app didn't even see the request. It didn't even know the request came in. No code was running. And if your app is using a web framework, which it should, it actually has a dispatcher internally. It doesn't matter which framework it is. But you're not going through the dispatcher. The app wasn't called at all. The furthest you can get from the app, the fastest you are all the time. So this is the second thing. The third thing a middleware can do is actually, once it gets the response back from the layer afterwards, it gets the response back after you called it, it can play with it. So you can add stuff to the response. You can remove stuff from the response. This is really interesting. You could add additional headers, for example. And I'm going to show you a few middlewares. Middleware rewrite allows you to rewrite paths that are coming in. It also allows you to return a different status if you want to, which is very, very, very cool. Usually we do rewrites on the server. Many times we do it in htaccess. Not all web servers support htaccess. If you put it here, and your stack, your PSGI code, is actually your app plus a bunch of middlewares, one of them being a rewrite, you can carry your rewrites with you to any server you want. Now, for some companies, us included, we deploy code all the time. And it's easier for us to define all of our rewrites in code and just deploy it. Changing configuration on a server, even if you have a nice Chef or Puppet setup, which we do, will still take longer, be less maintained, and your developers will always have to harangue your sysadmins to change this. You're moving all of the control back to the developer. Middleware cache actually checks stuff before and after. So before it checks, do I have it in cache? Yes? Screw it. Don't send it to the app. Send it back to the user from your cache. Oh, I don't have this? OK, send it to the next one. Maybe it's a middleware. I don't care. When I get it back, now cache it. Done. And your app doesn't know, but your app just received free caching. Done. No configuration necessary. In the app, at least. The debug middleware is so cool. It actually injects HTML and JavaScript into the response, so you suddenly have a menu to probe into your response and your request. This is incredible. It just injects HTML into the response. Why not? Because I can control it. I get it back. Reverse proxy allows reverse proxying from within the app. Auth basic, I find one of the more fascinating ones. If you do authentication, one of the protocols is auth basic. And we always put this in the server. We define htaccess, which is in the server as well. We define this is a path that you need authentication for. Here is a password file that you should use. And then we configure that password file. When we change it, oftentimes we overwrite it. It's horrible. But if you use this middleware, you can define all of your authentication in your middleware, which now goes into code. So now you can actually have a completely different authentication mechanism. Completely different if you want. I'm going to show this. So this is how we would use the Plack Builder, which is that DSL, to define middlewares. We basically say, use Plack Builder. Suppose that we have our app here, the sub. We call builder, and this is a code block. And we just call enable. And then we give the name of the middleware. Now, I actually should note, and this is a problem in the pod, that when you put something, it will automatically assume that it is Plack middleware, whatever you put in. I'm going to show an example of this. And we can also enable them one on top of the other, as many as you want. Just chain them in. And you can provide optional options here, optional options. And at the end, you give your app. So you're basically saying first layer, second layer, third layer, fourth layer, and so on until eventually you will reach the app. Every middleware just sends onwards. This is an example of some of the previous middlewares I showed. Enable rewrite, which will assume it's Plack middleware rewrite. If you want to give the full path, just put a plus at the beginning. And rewrite takes a bunch of rules. And these rules, well, in this case, it will actually try to rewrite /foo to /bar. And if it's successful, it will return a 301. This is kind of cool. You can return a 201 here if the path is fav icon. Auth basic, you just do enable auth basic, and you give an authenticator function. So you can now control exactly how it's going to authenticate. Maybe you don't want a password file. Maybe you want a third-party service. Maybe you want a database. You can control them. You can enable static, which provides static file serving. So your application doesn't handle static file serving. Remember, the more you get further away from your application, the faster it gets. So static, you give it a path. If it's /images, JS, CSS, this is where you will find those files. You serve them. Don't send them back to the app. Testing, which I talked about briefly. PSGI environment mocking. If I have use Plack, of course I had to screw something. Use Plack test, HTTP request common. And then you can create your app here, which has just, in this example, it just returns content. You create a Plack test function, object, and then you can call request on it with a nice get slash, which it comes from HTTP request common. It generates an HTTP request object for a get request to slash. You send it using the request, the request method, and then you can check, well, is the result that I got back the content of which is hello? That's it. And this will actually mock an entire server in the background without actually running any server, which is very, very useful. So now that I talked about PSGI and Plack, we do know they are great. And if you don't, I'm willing to go back and explain. So they provide us with a simple yet powerful protocol, and they allow us to standardize on one side, on one hand, the frameworks that we use, and on the other hand, the servers that we deploy them on, and just provide something that will always work, any framework on every server. Which is really nice, because it allows us to write really, really cool web frameworks. And it allows us to write really cool web servers that are no longer Apache or Lighty or something like that. We can actually write custom servers that do just this protocol. And they will be much faster, like Starman, like Twiggy. So suddenly I can run any event code in an any event server. Fantastic. But here's the thing. If you are a very large company, it's always a question of, is all these cool things, are all these cool things enough for you to consider this option? Because, you know, buzzwords can only go so far. And sometimes it's just not far enough. If you're a startup, you don't care. You just pick up the latest thing and you just use it, and that's it. It's good. Buzzwords, great. You know, unless you're Hacker News, you can't live on buzzwords. So the problem really is the B word. And you all know, I know I shouldn't say bad words, and it's not nice, but it is about business. Well, the thing is that if you're a very large company, you have to justify this for your business. You can't live off buzzwords. They don't provide any money, again, unless they're Hacker News. So when we take a look at stuff that we don't like in a large infrastructure, there's a bunch of things that people always talk about. For example, rewriting or refactoring is something that we always talk about. No, well, if you have a large infrastructure, you can't do this. That's actually not correct. The only thing you need to consider is there any value to this? If you're a responsible programmer with a lot of history, you will not have to think long and hard after I ask you, you either touch this code once every 6 months for 2 days, or you will now sit down and rewrite it for 2 months. If you know the code is going away in 5 years, it probably won't be worth your time. It just won't. You're not touching it enough times. You're not making enough changes for it to be worthwhile your time. And your time is way more important. So you can do this, but it has to have a reason to it. One thing that we always forget, code that makes money, you can't just ignore it. You can't just delete it. Maybe I have code in CGI, and I don't like CGI, but if it makes money, I can't just, the hell with it and delete it. It won't work. It's really, really, really bad. I'm now realizing I'm completely ignoring everyone here, and I apologize. So I'm gonna try. So the thing is that these things actually matter. If you're making money, you can't just say, well, I'm just going to not do it anymore. I'm just going to delete it. And a lot of startups actually do this. I know one company who tried to rewrite the same system with different languages because it was always the language du jour. Did I get that right? I probably massacred French right now. So it was always like the latest language. It was like, first it was Perl, but then it was Python, but then it was Ruby, but then it was C, but then it was... You can't do this if you already have a large code base that makes money. They weren't making money, so they kept just trying the next thing. And that was fine. Of course, at the end, they didn't really create anything, but they read a lot of Hacker News. Setup costs are a lot. So setup would be your dev environment, would be your KVMs, would be your deployment, would be your testing, all these things, staging. All these things cost a hell of a lot. And you can't just ignore all of these things when you look at a new technology. So if I take a look at PSGI and Plack and it says, oh, well, right now you're going to have to rewrite everything, or you're going to have to change all of the setup. Changing them costs even more than creating them in the first place because you have to tear it down in order to create another one. It's ridiculous. And one thing that developers always forget is that there is something called externalized costs, which means it's not just your time and effort. Maybe you're crazy and you work on the weekends until you get it done, but you have your sysadmins and you have your infrastructure people, and those are additional costs that you have whether you think they exist or not. And I know a lot of us don't like to admit that sysadmins exist, but they do. They do. I came from sysadmining. What are you going to do about it? So these things, they cost a lot of money, and you have to remember these when you take a look at a new technology. So they matter. And that's why a lot of businesses don't actually change to new technologies, because they think about these things and they go like, holy shit, I'm going to have to rewrite? No way. Oh, I'm going to have to change all of my setup? I can't. What about all of my code that I can't use anymore because it won't work with this technology? And they don't switch for, a good reason. Because the companies, they don't exist to make you feel good. They exist in order to make money. They sell a product. We all do. So when we take a look at PSGI and Plack, the question really is, how do we evaluate this with all of these concerns? In this case, I am able to provide a very good use case for this, which is Booking.com. Booking.com has millions of lines of code. Not one, not two. Millions. When I took a look at the number of modules that we had recently, it was roughly 1,000. Abigail informs me that I probably calculated differently and not correctly and incorrectly, and I would not be surprised.
Well, I said that's only because our packages are very large.
Yes. So
we would have normal size packages.
Right. So packages, the way you decide to split them off, and it might be even larger if you split them off more. So this is crazy. This is really crazy. The company was established in 1996. It is not a new company. It is not a startup. It has a bunch of code from that era. And some of the code that we have, not all of it, and I will repeat it often, some of the code that we have uses some old frameworks. things that if you would start from now, you wouldn't use. For example, class DBI. But you should notice that class DBI was founded in 1999. It was 3 years after Booking was founded. So when class DBI got into Booking, it was brand new. No one had anything like this. DBX class came out, does anyone know?
2005, I think.
You are correct, sir. Or, I'm sorry, was that Nick?
Yes, Nick.
Nick's the sir. So, you know, when people look at it now and go like, well, you know, you should use DBIC. No, it only came out in 2009. Imagine how much code we had then. 9 years of code. 6 of it was in class DBI. Mason. Some of the code actually uses Mason. But Mason started in 98. This was 2 years after Booking started making money. Well, as a startup, when it started, I'm assuming it didn't make a lot, but it was already 2 years as a company in that era. So, you know, HTML template, founded in 1999. So these technologies, we don't necessarily would use them nowadays, or I can say for all of these that I won't. But back then, they were brand new, and you have code that uses it. Again, not all of it. But some code actually does worse. Some code actually relies on specific servers or specific systems or specific platforms. For example, there is code that relies on using Apache and mod Perl. Apache starting in 1995, it was, oh my God, it was just invented. And mod Perl, the first indication that I found was in February 2000 as their first email on their mailing list. So these were, at least mod Perl was brand new. So we have some code that actually assumes you're running on these systems and specifically some of these platforms. And like I said, this is code that you can't just delete. You can't. It's making money. So what are the options of such a big company? I found 3. One is to rewrite everything from scratch. Another one is to write the new stuff in the new frameworks. And the third one, of course, to forget about it and stay sad forever. Let's go into them. First one, rewrite everything from scratch. That means that you will either have substantial downtime until you remove code from 1996, or you will need at least 2.5 to 3 times as many developers, because half of them will have to rewrite the old stuff, half of them will have to continually write the stuff that is still coming out. It's not that everyone is like code monkey, we're just writing code, but you will be writing code at least sometime during your job. So, no, well, unless you're a manager, I guess, right? But, you know, you would have to have some of them doing this. And the interesting part is that those that are writing along the current devs, most of them won't actually have the stuff that the first ones assume on. So you would have to recreate all the tools, all the setup. This will take you back. Now, it is important to note that as of this time, if I remember correctly, Booking has roughly 600 IT people. I want you to find 2.5 to 3 times as many very quickly. So,
Are you trying all the time?
we are. Yes, but we're not trying to get to 1,200. So,
We actually have more than 600.
damn it. OK, foiled again. So it is deemed by me practically impossible. The second thing you can do is write all the new stuff in new frameworks. So you would need multiple environments. You would need multiple frameworks. You would need some compatibility layers in between, providing cleanups, checkups, fixes, to provide everything that you need to make everything continue working, and a lot of emulation to fake all of the things that no longer exist in the stack. So the thing that you would actually get from this is simultaneous development at the same time. You would be able to maintain different environments. You would be able to maintain different frameworks. What would be considered different code bases could be maintained at the same time. You could continue to develop each separately at the same time. That means probably no downtime. That definitely means no doubling or tripling the number of developers. But it is very difficult. And the question is how? Hopefully I'll be able to answer it by the time I finish the talk. Of course, I did look into the third option because I'm very thorough. I did find out that it would be boring, depressing, and it wouldn't be a very good tech talk. So we're not going to do that one.
You will get to the pub faster.
You will get to the pub faster. OK, so how do we get beyond Apache, Mod Perl, Mason? And when I say this, I don't actually mean leaving them behind. I actually mean looking beyond them to be able to do more than just them. Because any code that uses them can't be deleted. It could be rewritten with time, and perhaps some of it will be. Perhaps all of it will be. But it wouldn't be just deleted. And that's very important. And this is the decision we made, and when I'm talking about this, I'm actually talking about the stack that Booking now has. First of all, we use Nginx as a reverse proxy in the front. We use micro-WSGI in the back. Now, you might notice that I was talking about PSGI, and this says WSGI. And I did talk about Python having WSGI, which is kind of weird. Well, micro-WSGI is actually a WSGI server. But because WSGI and PSGI are so similar, well, it implements PSGI too. So we can use WSGI as a PSGI server. It has a lot of cool features. Internally, we can have whatever app we want. Okay? We can have multiple apps. Something could be our internal thing. Something could be frameworks. For example, Dancer, which we do use. We will have to emulate, mock, fake, check, fix, improve, and all of these things. And we do that. We have all of that. And at the end, what we get is a durable, decoupled divergence of concerns, where we're able to have this separate from this. We can have Mason stuff separate from the Dancer stuff. We can have the Mod Perl separate from an internal PSGI app which is not using Mod Perl. We can have a new product out on the same stack that is separate. Let me illustrate it for you because my ASCII skills are insane. So you have the web server in the front. I kind of don't have the reverse proxy here. And underneath, you have a PSGI app. And that PSGI is wrapped with middlewares. And those middlewares can handle static content. They can handle authentication. They can do a lot of things. From that point on, the PSGI app itself, because these are all callbacks, we can continue using callbacks within it. So the PSGI app can then continue to other PSGI apps. For example, we have a PSGI app here that is using Mason with a Plack handler. So we have to fake it somewhere that we're actually, if it assumes on Mod Perl for the Mason parts, that we do use Mod Perl even though we don't. And it will use the Mason with Plack handler. We can do the same with the PSGI app in Dancer. We can do the same with some internal app. And that's how we can actually diverge into different separate streams, if you will, of applications. All of them under the same stack eventually. Now, I would like to finish it, and this will be probably a bit early. I would like to finish it with a few tricks that we have. There's some of the things that we use. I wanted to share a lot of those. I'm going to start with very few, and if this goes well, with time, we'll share even more things. And there's some Plack tricks that we use for our advantage. Either stuff that are very useful or stuff that I found very cool. First of all, we preload everything before we fork. So when micro-WSGI starts, it has to receive that code that it will store and call every request with. But it will actually fork before it starts serving those. So what we can do is preload a bunch of stuff lazily before we construct our stack. So you basically preload, create a stack, send it to micro-WSGI, and then it forks, which reduces memory usage considerably. Very cool. I really like this. Another thing that we do is asynchronous cleanups of our applications and contexts. So if I have a sub, which is the app, I can define another sub, which is the cleanup after request that will call all of these cleanup handlers. And we're using an extension of PSGI called PSGIX cleanup. Okay? And if we do have that ability in the server, we will put in our PSGIX cleanup handlers this code. And then our server, in this case, micro-WSGI, which supports these, will actually find this after the request ends, return it to the user, the response, and will run this cleanup asynchronously. This is, by the way, one of the reasons we use micro-WSGI. Smart authentication. When I talked about having an authenticator, which is whatever code you want, we actually utilize that ability to provide different authentications for different situations. Oh, you're going to a server that implements this API. Then we will authenticate according to this database. oh, you're going to a server under this path. That's fine. We will now authenticate using this thing. So you can use LDAP, databases, third-party services, whatever it is you want, to have different authentication techniques. If you try to do this in a web server that has hard-coded rules of what kind of things I can do, which is usually HT password, that would suck. So this is something we use for our advantage when we take all of the responsibility and all of the control back to the developer, who's now able to do whatever they want. And when I talk about having very smart authentication, we actually use another trick. Does anyone know bash.org? Raise your hands, please. This is good. So bash.org contains IRC conversations that were either silly, stupid, smart, funny, usually just funny, or stupid. And there was a conversation where one person was able to convince the other person, without him knowing, to share the password. The password was Hunter2. We use the ability to have our own authenticator to check if we're running a development server. And if we're in a development server, we allow different passwords. One of them would be Hunter2. One of them will be 7 asterisks, which was considered the encrypted version. And we allow, of course, sandhash. So if you're using a development server, we have a KVM, okay? And I have an API in this KVM, and I want to call that API from a curl, from the command line. I just want to run a request. I'm not going to put my password on the command line. If I want to send it to someone, and I'll send it with the username and password, I don't want to send them with my password. So we can all use these passwords on our KVMs. Now, if this is in production, it won't work. But in all of our internal systems, it does. So your development is not slowed down. And there's, of course, link to bash.org 244321. Check it out. It's pretty funny. The last thing I'm going to show is my very favorite. It was written, as the other examples, by Ivar. It is the sanity destroyer. And he requested that I would put the pod description, which is, come on, why didn't you just use this package name if you had the chance? The sanity destroyer does something very interesting. What we do is bless an object to a certain state. We are able, on destruction, to change that state. And we are able to then probe that state. What we do with it is put it in the environment, reset to a new state. Now, what happens when a request ends? I'm going to explain one thing, then I'm going to ask. The environment hash will be cleaned up. If I have an object in a hash that gets cleaned up, does anyone know what happens to that object? It is destroyed. Good. Good. Good devs here. So have you ever considered a job? So the object will get destroyed. Now, when an object gets destroyed, what happens? Core developers are not allowed to answer. What happens when you destroy an object? What was that? Right. This destroy, if you provided one, will get called. In our case, if we clean the environment and there are no more references to the object, it will be dereferenced and cleaned up, and its destructor, if provided, in this case it is, will be set to a different state. Interesting, because then we can check, hey, was it destroyed? And if it wasn't destroyed, we can say, wait a minute, we didn't destroy this. This means that our last request, the end, wasn't actually cleaned up. This helps us monitor memory leaks in runtime. It is incredible. This helped fix one major memory leak in Dancer 2, which in the latest version doesn't have. And it was something that was very hard to find, and this helped us. And this helps us find mistakes that we make that might create a memory leak. We will see this right away. So, what are the conclusions for this talk? Well, first of all, that Plack does provide us with a durable decoupled divergence, with the ability to separate things and maintain them. That means flexibility. That means adaptability. That means a migration path. from whatever old versions of modules or whatever, I should say, code that we don't want to have anymore to a new version, from services that were written under old code to rewritten code. And we can just do this cleanly without actually worrying about destroying anything. It allows us to continue to innovate, which means to create new cool things without worrying about, oh, damn it, I'm still on Mason. No, I'm not. I can continue my work while Mason is still being developed. And of course, all of this at a reasonable price. Which, kind of my conclusion to this is, development is being able to move forward without forgetting the past. It is progress to be able to progress without being slowed down by the past, but without throwing it away with kind of a lot of money in the process. Thank you. Now, does anyone have any questions? Really? No one had any questions about this?
Still absorbing. Are you hiring?
I'm not sure. I'm not sure.
Does it have to be about this?
This is not...
We hear you.
Yeah,
you don't like it, but we hear you.
Sorry about that. This is not a question, just a comment. I think on your second slide on the top you had a typo, like you left a placeholder and...
Most likely. I was working the slides up until now, trying to clean them and of course, ruin them. You know what? I do think we are hiring. If you want to work on any of these cool things, just talk to us.
Amazing.
Well, the fun part is that you won't have to. That is the fun part.
And there are more tricks to discover if you like to see out there.
Yeah, there are a bunch of other tricks. With time, we might show some more. We will definitely show some more. Oh, one brave soul. Go ahead, shout into the microphone.
Can you handle 2 user requests at the same time within one parallel process? Is there a way to do it?
If you have an asynchronous server that has an event loop, when it comes in, you just throw it to one place, and it will run it in the event loop, so it can receive more things at the same time and throw them to other places. But all of your code will have to be event-driven code, and the server will have to be that way too.
Do you do that?
We don't use that. We use MicroWSGI. The only thing asynchronous that we use about it is the handlers. But MicroWSGI forks, so we could do this. So Booking does handle more than one user at a time. And it's not just a server per user. We use MicroWSGI, which basically forks. So it has multiple processes. Any other questions? No? All right. Oh, yes. No, you have to wait. There's nothing. Okay.
Yeah, I noticed the part where you said that you can do authentication in various ways. This specific slide, and I was wondering what is the approach to authenticate when user connects via SSL with certificates, because honestly I can't find anything on this. So the setup is that there is a dancer application and it with a PSGI environment, and then somebody connects and I want to check if his certificate is the one that I need. That's it.
Okay. So basically Plack doesn't really do SSL. This is left to a server. The server will have the SSL certificate. The server will do all of these things. PSGI will tell you, as part of its protocol in the env hash, if it is a secure connection by this time.
So it has to happen completely at the server.
You should put it at the server layer, which we do. The authentication that I showed is not actually for people who use the website to make bookings, but it is for authenticated services. For example, our API or internal services as well. All right, so if you, oh, yeah, last one. Yeah, he deserves it.
I was just wondering if there were any other PSGI-X extensions that you guys were using that you found really cool.
A ton. See me
Tell
after.
me about one of them. Go.
See me after. I don't have enough time. So thank you. And if you want to grab me for any questions, I will try to escape very soon.